Okay. Let's say, Caroline, why don't you help us with this? What's the answer? Right. Exactly. Fundamentally, the open access is going to be limited by the existence of scarcity rents or economic profits. As soon as the scarcity rents go to zero or the economic profits go to zero, they're going to terminate their effort. Right? That's the bottom line. But obviously, nobody wants to be involved in hunting down the last whale, right? But in addition, it's going to terminate when the scarcity rents go to zero, and that's represented, as I've indicated, by the average cost being equal to average revenue. And as a result, as Caroline just explained, the open access did not cause extinction because the actual limit is the existence of the scarcity rents or some positive economic profits. All right. Fundamentally, we all recognize when there's free access, we invite the tragedy of the commons, and recognize that as long as there's free access, there is no limit on the various individual profit-seeking companies or entities to preserve the resource, unless, of course, the preservation level takes place at a point at which scarcity rents are completely dissipated. Okay? And that's my second bullet here, namely, they will continue to increase their efforts until the profit per effort goes down to zero. Okay? Now, in evaluating any open access fishery, it's important to keep in mind two types of external costs. And by external cost, I now mean, up until this point throughout our lectures, when we talk about external costs, we were generally talking about externalities. Now, when we refer to external costs, there are costs that are not borne by the fishermen or by the fishing fleets. Those are costs that are borne by others. And I make a separation here between current external costs versus future external costs. The current generation ends up bearing too much of the cost of overfishing. Too many resources in an open access fishery are engaged in the actual process of fishing. Clearly, if you don't stop at the efficient level of effort, and you go beyond that point, you're going to have to draw resources in for doing so. Additional labor, additional fleets, additional boats that will end up being inefficiently employed in this economic activity versus other economic activities. Okay?
This is a lot like the situation at the post office now, where we have to make specific but like a main argument is that there'd be a lot of jobs that you use the economy with now. So what's your counter proposal to that? How do you combat the idea of a lack of jobs being an incentive to keep something less efficient in the short term?
That question is beyond beginning economics. But nevertheless, I'll answer it. Jobs, at the end of the day, much of our economic analysis presumes that resources are fully employed. Okay? If you have idle resources, idle labor, then that turns a number of our fundamental principles in economics upside down. But having said that, if you've got a very inefficient service that's being provided, if you go back 30 years ago, the U.S. Postal Service was an efficient service. Subsequent innovation has taken place. There are all sorts of much more efficient substitutes. And if that wasn't a public entity, given Schumpeter's innovative destruction that takes place, it would have been closed down long ago. Right? And the only reason it hasn't been closed down is because of what you recognize, namely it's going to have an adverse effect on employment. But that's not the real driving reason that the U.S. Post Office is still open and still generating huge losses day by day. It's because a lot of local communities depend heavily on that postal service. A lot of people, in large part because of legacy and tradition, continue to go to their mailboxes each day and pull out whatever hard copies of mail that exist and still use that. And it turns out to be very important in rural areas where a number of the substitutable communication products that are available aren't used in some communities. Having said that, at the end of the day, we're, as a society, now I'm going to jump well beyond this course, society is much better off not by employing people to avoid unemployment in activities that are losing propositions, that use up scarce resources, that don't generate any value. But politically, that's very hard for our politicians to do. We're better off by actually promoting the efficient uses, given the value that's generated, then redistribute that value to train those people who are unemployed, to provide education so that they can become gainfully employed. That is the efficient solution. It, however, is not the politically efficient solution. Right? Okay. Intergenerational external costs. As you overutilize that open access resource, you end up reducing the amount of stock that's available, and moreover, depending on where rents are totally dissipated, you may end up with extinction. And if so, future generations aren't going to have access to that resource. So that is, even if they do have access, they're certainly not going to be able to generate the incremental value that they would have, but for the overutilization of the resource. All right. So what have been the policy responses? What have governments done to correct for these various sources of inefficiency? Initially, by the way, when you look at public policy, you look at how public policy has been designed to deal with inefficient use of renewable resources or exhaustible resources that we've been evaluating. If you look at the first attempts on the part of the public sector, your natural inclination is, gee whiz, they actually tried to impose that policy, hoping there was going to be some greater efficiency in the use of the resource? Or was it simply done to serve political powerful groups? Because they don't make any sense at the end of the day. The first policy was to increase the cost of fishing. If I increase the cost of fishing and I move up that total cost curve, then it will be in the fishing fleet's self-interest not to fish quite so much. And those kinds of increases in cost come in the forms of you can't use certain technologies, they prohibited the use of certain traps to catch the fish, long line nets were excluded, all of which had the net effect of increasing the cost and thus limiting the number of legal fishing that took place maybe also with regard to a particular fishery, they limited the access to, say, Tuesdays and Wednesdays during the season. And you can't fish on Mondays through, what did I say, Tuesday and Wednesday. You can't fish Monday, Thursday, Friday, Saturday, Sunday. All of these kinds of policies had the net effect of increasing the amount of labor and capital that was required to catch the same number of fish. The fundamental problem with this policy response is that even though you can increase the cost up to the point where the amount of effort would be the point at which we're at cap E superscript E, namely what was formerly the efficient solution, but in doing so, you're going to end up with an outcome that requires too much in the way of resources, too much in the way of cost incurred to capture that amount of fishing. And this is illustrated here. This is the original total cost curve. And this particular policy comes along and says, listen, I'm going to impose all sorts of restrictions, and I'm going to increase the cost of effort, whatever effort is conducted, and I want to get to a point that's related to the efficient solution. And I can get there by continuing to raise the cost until, of course, this particular intersection takes place. And by the way, at that intersection, is there any scarcity rents? I mean, you still have an open access, but what you've done is you've increased the cost through the restrictions, the public restrictions, so that what was formerly the efficient amount of effort now is also the amount of effort that would take place through open access. Okay? And moreover, these kinds of policies invited improved technologies under the restrictions, whatever the restrictions are, the regulations. And it turned out that fish finders, stronger engines on the vessels, all ended up reducing the cost, and thus there was an ongoing game between the regulator, who's trying to increase the cost to reduce the amount of effort that is being expended, and the private sector companies engaging in investing in new technology to lower their cost. And as a result, end up increasing the amount of effort out to the point at which scarcity rents, once again, are completely dissipated. Okay? So this particular policy of increasing the cost that is incurred turned out to be a policy that, one, was not efficient, two, invited strategic behavior on the part of the fishermen, and still ended up with over-exploitation of the renewable resource. So what do we offer instead of this particular policy? Namely, introducing another substitute policy, namely taxes. Regulators can impose taxes to create the same kind of cost structure. And in imposing taxes, the government, in effect, acts as the owner of the resource. Right? And this is a subtle point, to keep this in mind. The tax can, in fact, move the cost curve from TC1 that we had in the prior figure to TC2. But in doing so, in increasing those costs, you're going to employ the resources, the labor, the vessels, the amount of capital equipment efficiently. It just so happens that the private fishermen are not going to capture the scarcity rent. Instead, the government, if it sets those taxes properly, will capture the scarcity rent. And this is shown in this next figure, where I got the tax represented by a blue line. I add the total tax to the original cost to get the total cost that's facing the independent fishermen, women. Okay? And if I set that tax properly, I'll get the efficient level of effort, cap E superscript E. And if the government sets the tax properly, the government, will capture all the scarcity rents. Let's look at this graphically. Okay? It's the same story as we had before, where before this was the total cost, we imposed the tax represented by this blue line here. We add the amount of the tax to the original cost, and we end up with this being the cost here. Right? And once again, now the efficient level of effort is going to be that level of effort that is going to result in the total dissipation of scarcity rents after taking into account the tax collected by the government. Now, you may stop and ask yourself intuitively, wait a minute, you just went through and you showed when I use another way of getting to TC2, I get to the same outcome on this graph that I got with just increasing the cost. Right? What's the difference between the two? Think about it for a moment. This is not an act of learning, but it should have been. Because it's a fundamental point that requires real skill with regard to applying the fundamental principles that we've covered throughout the course. Remember that I said, when I look at the first policy, that you can actually get to this level of effort, but you're using too many resources to get there. The regulator is imposing these additional costs on you, and you're achieving that efficient level, but at a non-efficient cost. Okay? Now here, what's different? Because is this do we get to that level at a non-efficient cost? We still get to the same point here. Right?
It's efficient because they're able to use the fishermen are able to use the technology. So
the most efficient technology, right?
It's like building a house with a pneumatic gun as opposed to a hammer.
That's a good analogy. Right, but the point is we're getting to this point at the
cost is the government because they're just raising the taxes and they're getting this tax money basically, they're just able to pile it up and distribute it.
You're right. In one case, all you're doing is transferring resources. This policy is transferring all of the quasi-rents to the government, right? But I'm doing so efficiently. In the prior policy, in which the regulator is increasing the cost, right, and the cost is being increased because you're using too much in the way of resources, you're getting to that outcome, namely cap E superscript E, but you're doing so in a very inefficient way because you're incurring much more in the way of cost of resources to get there. Right? Okay. In one case, you're transferring resources given an efficient solution. In the other case, what you're doing is employing too many resources to get to the efficient solution outcome in terms of effort, but using too much capital, too much labor relative to the efficient outcome. Okay, now, the tax is certainly preferable as a result over just trying to increase the cost of open access by various fishermen. And this regulation ends up increased costs by inefficient methods. I've already said that. The tax, however, will not do so, and it will raise funds for the public sector, for the government, that can be used for other public activities. Investment in public education, in public good research. And in the second policy, the tax is an efficient mechanism for transferring the harvesters or the fishers' income to the government. The problem is that no fishing firms find that solution very attractive. Surprise, surprise. Why in the hell should I spend my whole life running a fishing firm if all I'm going to do is transfer whatever positive economic profits I can make to the government? Right? And those particular firms have some political power, so if we look in the United States or the EU, are there any fisheries that are managed this way? No. And the one solution that works, and I'll stop here, is transferable quotas, property rights. What are our three conditions for well-articulated property rights? Exclusivity, enforceability, transferability. And if you can design such quotas to get there, you can achieve efficiency. Thank you for your patience.